I had just the most retarded thing happened to me. Actually, I fixed the driver pretty fast. I did end up fixing it for the in 10 minutes, and then I had like a broken sound for some reason. And when I fixed the sound, I forgot to switch the stream on, and I was like talking for 20 minutes or something. And only then I found out that I forgot to like turn stream on, and yeah, this was really silly. Okay, let me try to like go second time for the show you the second time that I was doing here. So the first thing that I wanted to show is to show the light model here, which is like this thing. If I do this, then yeah, this is what it looks like. And yeah, I need to do this and composite, and yeah, show the only primary color here. Yeah, so this is what it looks like. The shadow model, and yeah, you can see that this is a mixture of the shadowing with the ambient occlusion. It can't be properly seen here, but if you have a lot of lights everywhere, it does look like these blurry shadows, and it's better. Okay, so this yeah, this was this, and okay, I close this stuff, and then what I wanted to do is to show the separate textures. So the texture number 0 is the random texture. The texture number 1 is the texture of the primary ray, which is in linear color, looks like this. So yeah, really dark and bad. This is a reflection texture, which is looks like this because this is a rough surface with a lot of irregularities, and yeah, this is the puddle of water, and this is this material is also reflective and smooth. And then this is a first blur, which is like blur reflection, which is looks like this. It's really simple, like a lot of samples around the central sample, and it checks whether the material, whether the surface is a continuation of the same surface. This is central pixel, and only then the color is contributed, which is like only if the roughness changes a little and Z, so the depth changes a little, only then it considers it to be the same surface. So you can see here, like even though those surfaces are really close in terms of Z, in terms of the distance, they are blurred completely differently. Yeah. And this fourth texture is the second blur texture, which gets more blur, and it actually is the same. The same except for the number here and number here, which is the texture where it samples the color. And it ends up compressing really good because basically the sources are the same, and this index here is the only thing that is different. And I was afraid that I actually will end up writing something to pass the texture index here and here. And I didn't, because it compressed really well and it was helpful enough. So the next thing is the combined texture, and I will crank up colors a bit to show it to you because it's still in the linear color space. And what it does is this. Basically, it reads two textures. The first one, the primary one, and reflection one, and also it reads like two blurs, and then it does a linear interpolation between the first reflection and the blurred reflection. If the roughness is between 0.1 and 0.2, and the first reflection and second reflection if the roughness is between 0.3 and 0.6. It's completely not physical, it's horrible, and it does look bad in some situations, like in most situations I'd say, but anyway, it is better than nothing, and this is only what I could come up with in limited time. So there is a proper way to do this, which is image-based lighting, and I will read papers on that to understand how should I do it properly, but for now it's like that. It anyway turns out to looking quite okay-ish. And then there's depth of field, which is okay. I will need, and this I need to make smaller, which breaks into two fields: the near field and far field. This is the near field, and this is the far field. Okay, it's let me just this is the far field and this is the near field. So they do have, like, they don't intersect at all. There's a strict border between them. And it's possible to the structure of it is really simple. I do a lot of samples around the central pixel, and this is the COC, circle of confusion calculation based on the distance of the focus, aperture size, and something that represents the field of view. I don't remember how it's called, and the distance to the actual pixel. So basically it's a little bit of reverse. So I calculate the supposed circle of confusion for the sample pixel, not the central one, and then decide based on the distance of this pixel whether this sample pixel should contribute to the central one, and if it should, then whether it should contribute to the near field or the far field. Near texture or the far texture. It's also possible to like tweak parameters here and get more blur, but mainly the blur here is limited not by this thing but by the number of samples, because the more samples I have, the more the wider can circle of confusion get, because number of pixels determines the radius of the sample pixels. So I can do stuff like this, and it will get, but at some point if I write this, I think, yeah, it will be limited by that. No, it won't get much bigger, and if I do this, it will be still small. So it doesn't like make a lot of sense to do really blurry scenes with this technique in particular, because it's limited. Okay, and the next texture number 7, is actually that is the far field, and the 8th texture here in the tool is the output texture. So it's a proper gamma corrected color, and the shader that outputs is the post-processing shader, which is consists of first thing that it does, it mixes the near and far field with depth of field textures. Basically, this is the function that I came up with that does mix them in the right way. Привет, КДС. Я рассказываю про то, как устроена интро размером 4 килобайта, которую я сделал и которая заняла 6-е место на Assembly в этом году. Вот на этих выходных было. То есть это exe файл размером, вот итоговый получился 4005 байт. Вот я рассказываю в основном про визуальную часть, а аудио-часть была очень плохая, я про нее, наверное, практически не буду рассказывать. Вот. So, and it also does, the shader also does the chromatic aberration. So these blue and red displacements and the edges of the frame. Ссылку на конкурс сейчас. Так. Ссылка на конкурс. Так, а ты с какого чатика? С этого, с Пикача, да? Сейчас. Ну, сама главная ссылка это вот assembly.org. А на мою работу конкретная ссылка на... Ну, там можно у них жмакнуть на... У них где-то есть видео, ссылка на их YouTube канал. Или, может быть, вот здесь есть. Да, тут есть, в общем, всякие эти... Можно жмакнуть и посмотреть работу. Моя работа называется Placeholder. Где она? 4К интро. Вот это вот. Okay, so next thing that it does is tone mapping, which is a simple, I think it's Reinhardt called, and the gamma correction from the linear color to the gamma corrected color for the output. And then it does the filmy grain. I can disable it and it will look like more plastic or something. And then it does the vignette that I actually forgot to enable for the final executable file, but it won't take any much space. Like it will cost about like maybe 10 bytes or something. And I did have that amount of space left. На английском стрим, потому что ну вот так. Я делаю часть стримов на русском, часть на английском. Сейчас хочу на английском, потому что контент может быть интересен и англоговорящим людям. Вот. Ну, то есть на русском на вопросы на русском я отвечаю на русском. Но основной вот контент сейчас для этого стрима идет на английском. So, and this is it for the visual part of the like shader pipeline. So the shader pipeline looks like this. So there's like 7 it's actually 8 textures, with the 0 being the random noise texture, and the 9th is the output. Yeah, there's 8 textures actually. 8 textures and 1, 2, 3, 4, 5, 6 shader programs that read and write those textures. And yeah, the next thing that I wanted to show is the actual C code that does all of these for the intro, and it's really simple. It's an entry point, not main file, not main function. It's an entry point without anything, because I compile it without the C library, without any any unnecessary dependencies, and it does. Привет, Tesla 1856. Да, я успел на ассембли, но я не успел сделать звук ей нормальный. Я не успел как бы дополировать, я отправил как есть и занял почетное 6-е место из 12. То есть такой среднячок. Вот. So this one changes the video mode for the, I think my target resolution is 720p. It creates a window. Спасибо. It creates an OpenGL context. It loads the OpenGL functions that aren't linked by default. It initializes the intro. It initializes the sound output, and it loops until there's until it runs out of time or the escape key is pressed. And it takes time, and it paints at this time, it swaps output, and it fakes the message processing for the Windows, so that Windows doesn't close this program as doesn't consider it as hanged. And when it's closed, it's just exit process, and yeah. And basically, I do have a lot of textures and stuff like this. I do use enums to name stuff. So there's like those are passes, render passes, and these are textures. And although I have a special array for the sampler, the samplers that uniform samplers that get uploaded to the OpenGL program, those are static. They don't change. I just upload them all at once. I also use these for the multi-texture frame buffers output. And yeah, basically then I have list of programs, list of textures, list of frame buffers. So the program count is the render passes number, texture count is the basically texture count, and frame buffer count is the pass count -1, because the last pass outputs directly to the screen. And then this is really simple boilerplate for 4K intros OpenGL, except that usually intros do have only one program that does stuff, and they don't do any post-processing. And yeah, so intro init does creates the right number of textures and frame buffers. It initializes each texture. The first and 0 number texture is in random noise, which has its separate special parameters for the types and the special size. All other textures they have the same type and same size, although it would be possible and actually beneficial to have like blur and depth of field textures have less like half resolution, and second blur probably in quarter resolution, but yeah, I didn't have enough time to try that. And the thing here is that each texture gets bound for its own active texture, and the list of this function actually compresses really well, because it's basically it's the same code. It all over it's the same. Only difference with these numbers here, and it compresses really well. The same goes for the frame buffer initialization, which is like yeah, also the same code, only numbers change a little bit. And as you can see, the init frame buffer has 2 parameters for the textures, and only 2 frame buffers have more than 1 texture as for the output. And then there's programs get created the same, so this compresses really well. So the init texture does this, the basic stuff. And I actually forgot to set wrap mode to the clamp for the final intro. So not final, I mean for the released one. So there are color leaks from in borders there, and yeah, completely forgot to do that. And the frame buffer just bins textures for color attachments for the past textures, and I tried to check this here and it compresses really bad for some reason. But if you if you still like try to attach a zero texture, it will be fine. And yeah, I ended up using like this, and it also does compress really well. And then the paint stuff just simply goes through all the passes here, calls the paint for each program. Like the program this should write to this frame buffer and should have this number of outputs, and the final pass obviously has one output for the zero frame buffer, which is screen. And the paint here is just use this program, bin this frame buffer. If the frame buffer is not zero, then do draw buffers thing, and then probably I could have like do zero here, but I haven't tried. And then I'll upload the uniforms to the right location. So the S is samplers, and F is generic floating point parameters. Yeah. And then the draw is the GLRex, which is really easy and cheap way to draw stuff full screen. So there's nothing there except like full screen quad that does a lot of really expensive shader processing. Yeah, and this is it for the visual part. And the sound part was done like a couple hours before the deadline, and there was a lot of things that I didn't know how to do properly. Like for example, I had to do this assembly sign function, because if you do like call this usual C sign function, it will try to link the math library, which I don't want to do. So I ended up just using the inline assembly for the x86 sign instruction, which is not really that great, but for this purpose it's fine. And the same goes for the fractional part of the f for the floating point. If I write it like this, then I actually end up with rounding the floating point number to the closest integer one, so it won't be like the fractional number, but something else entirely. And this one, so if the floating number is greater than 0.5, it will round up, and if it's less, it will round down. I actually not sure why is that, so I ended up writing this assembly, which does work as expected. So I do lower the floating number and store it as an integer number, and then like subtract one from another, and it ends up fine. And then I do build a division remainder based on the fractional part, and then a couple of other helper functions like clamp number to the range. And then I tried to do some kind of sequence here that I didn't had time to finish, and yeah, this doesn't make any sense right now. And then I tried to do some timeline, also doesn't make any much sense. And yeah, then I tried to do these sound related functions from my tool, from my DSP assembler tool. And then I tried to have some kind of structure here with number of voices and synthesizer function for each voice, which ended up sounded bad for some reason. yeah, this is not really thought. I didn't put any amount of any good amount of effort into just this what I could came up in a couple of hours. And then I try to like synthesize the sound and this function, which is like a separate thread. And yeah, I tried to do delay. I also tried to do some reverberation there, but I ended up I didn't have, like, it was like last 10 minutes before the deadline, and I wasn't able to get anything good out of that. So also I have thrown here a bit of random generated patterns, but it's not in this source. I haven't committed it because like it was the last change that I did before submitted the executable file. I just simply forgot to commit it. It was a separate machine. And yeah, this is pretty much it. I think I will pause for now for 5 minutes or something, and or even less, and I will show you the Crinkler output for the final executable, how much space each thing takes. So I will be back in a couple of minutes. So I'm back here, the Crinkler output, Crinkler compression report for the executable. Yeah, yeah. And here, how it looks like. So basically I'm at 4005 bytes, so I have almost 100 bytes left and no time left. I think like the final thing here is like 5.5 minutes past deadline, which I don't remember. I actually, maybe my clocks on that machine is skewed, because I think I was like, I uploaded past the deadline, but yeah. Anyway, this is green color stuff. It's not interesting for this purpose. This is the 400, almost like 500 bytes is the native code, entry point code. As you can see, this is a basic initialization of the like video mode, hide cursor, create window, create original context, load optional functions, and stuff like that. And then there's generate textures, generate interesting. Yeah, this is generate frame buffers, but it, for some reason it isn't. It isn't named because it's extended function that I have to load here. So yeah, it doesn't get any name here. And there's init function, init texture, which it ended up being not in line for some reason. Which is interesting. I'm not remember doing anything. Anyway, you can see that this entire call takes like 2 bytes, and this 1.5 byte. Like, this is really cheap. A lot of repeating patterns is really cheap. And then calling the doing the frame buffer initialization, which is also cheap. Like this is even less than white. And then creating programs. The first of these calls are expensive, and then it gets really cheap again. What is this? I don't understand why this is here. Anyway, this was initialization. There's still a couple of things to try to rotate this code to make it compress even better. But yeah, this will be another time. I will try to do things more. Basically, one thing that I wanted to do is, like, as you can see, there are a lot of call instructions intermingled with the push instructions, and for the most part, most of these, it would be possible to like move all the pushes to the beginning, like to do a series of pushes, which will compress just fine, and then do a series of calls which will compress also like better than trying to mix them. I tried to do that in assembly, but on a low count of functions it doesn't get compressed that well. But on this amount of functions, I think it will be beneficial. Sorry. I will try to do this next time, and yeah. There's even more things to try, just to, like, not to push things, but have a prepared stack that you can like roll out and use directly. Like, just copy from some area to the stack, or even use some data writable memory for as a stack. Yeah, there's several possible approaches to try, and I think it will be possible to like win tens of bytes there, but we'll see. This is like not really that interesting, just another initialization which takes some bytes, and then paint. And the paint is also pretty cheap. Like, there's 2, 2, 4, 8, 2, like 10 bytes per invocation. Even less for the further ones, like 1. This is 1, this is 1, this is okay 1, and this is okay, this is 2, and this is 1. Okay, this will be like 5, 6 bytes. And yeah, this is cheap. This is completely unnecessary, for example. Like, oh, okay, no, this is necessary. This is for the big message. This is expensive. Okay, it could be, probably could have been done in a simpler way, because this takes a lot of, not that much, but still an unpleasant amount of bytes. And yeah, this is basically the entire native code. Not the entire, we have a init frame buffer function, which takes 33 bytes. Timeline updater. This is horrible. So it does load the floating point number. This is my custom sign function, which takes 18 bytes, even though the entire sign function is like 2 bytes original and 3 bytes compressed, because like this is byte context here. Yeah, this can happen, but yeah, sometimes it's like only 1 byte can take only like 2/100ths of a bit. But sometimes it's another way. 1 byte takes like almost 2 bytes, because it's like a really unexpected byte there. But anyway, this is really expensive. And yeah, it does stupid things, like it stores the floating point to this stack and then loads it from again, and there's a lot of optimizations possible. Any texture, which is also kind of okay-ish, but it still would be possible to make to be better, because as you can see, like it's when we call this init texture here, we do pass here we do pass parameters for it here, like this stack parameters, and then we do the same, we like re-push the stack or some, yeah, it does pushing again. Maybe I tried and it turned out that not in line in this function is better. But anyway. And then there's a lot of these functions, which is also like not that good. I actually haven't looked at that. So yeah, at this point the context is really good, so this 4-byte instruction gets compressed into like less than 1 byte, because it was really expected here, possibly to the series of the maximum unclamp, because it has the same series of similarly looking, yeah, this is basically the same, these and these are the same. Sign, yeah, I really want to rewrite all of this in assembly, because it's not optimal. Node to delta frequency, paint function, yeah. This is noise for the sound. This is timeline, which looks horrible. A lot of bytes, like 200 bytes for it. But anyway, I had a lot of space and not enough time. And then this is baseline generator, which is also bad. $100 byte for it. Key drum generator, 50 bytes, 18 bytes for the snare, and the 300 bytes for the sound generator overall. Anyway, this was the native code. So the native code takes 1.5 kilobytes. And now for this shader. So this is sprinkler stuff. This is what? This is some random stuff. This is the sound. So wave header for the sound initialization. This is some number. For some reason it's stored there. Another number. So these are numbers. So which one? This is also some number, right? Okay. This is weird. But anyway, this is double for some reason. Okay. So header. This is the this is an indirection. This is a pointer to header. So the actual contents are here. This one is the okay. Let's go from the top actually. So this one is just a bunch of this is samplers. So the 10 bytes for numbers of samplers that get uploaded to the uniforms. The draw buffers is constants for the draw buffers to tell OpenGL how many texture outputs we have. Names of necessary OpenGL functions, 90 bytes. This is for setting video mode. No, this is for generating the initializations of OpenGL context, pixel format descriptor. Screen settings is for the video mode. So 11 and 9 bytes there. Wave format, another thing for the sound. It's getting pretty late and I'm sleepy. And yeah, this is pretty much unused SAM sequencer. Okay, the next one here is this is the header. The header was written by hand. It's not packed by the shader minifier, but it's not a lot of code, and it should be pretty much. I can't run it through the shader minifier because it will mess up the variables, and I do need to have those consistent for all other shaders, because this header is used for all other shaders too. It takes 150 bytes, which is a lot of bytes. The next thing, I think this looks like the combiner for the reflected and primary ray, which is 100 bytes. Okay. And the next thing is which one this? I think this is blur first. This is second blur for the reflected ray, and this one is this first blur for the reflected ray. So as you can see, this takes like 15 bytes, and it is almost exactly the same as this one, except for these numbers here. everything else is the same, so it packs really well into really small size. Okay, the next thing here is so how does it look like? It looks like the post-processing shader. Yeah, it's the post-processing shader. And it takes like 115 bytes. I want to close all of this. And the final and the most heavy shader is the this one. I missed this one. This one, almost 170 bytes, is the it's depth of field. Depth of field. And it could have been optimized better by hand. There's like, I actually need all those floating point declarations. They can go directly as arguments to the next statement there. But anyway, so 170 bytes. And the most heavy shader is the ray margin shader. And yeah, it takes 1245 bytes. This section is probably, yeah, this is the colors, so it compresses really well. This is the light sources. So basically there's a lot of the same code, same structure with only a couple of numbers changing. But nothing really bad apparently. Like this symbol Q, letter Q, is almost unused, so it's really like weird to see it there, so it takes a lot of bits to get. Why is this expensive? I don't understand. So this might end up being bad optimization actually. So I tried to do this thing here where there's a special constant vector which contains value 0, 1 and some epsilon like dot like 0.01 something that I can use Swizzle to get all kinds of vectors of those values. But I'm not sure that it's actually beneficial, because where I see this vector used is like it takes a lot of bits. I would need to do some testings for that, but yeah. Anyway, this is it. This is the entire intro and how it's there's also like a Visual Studio project where I can hit build and it gets compiled and packed into the small executable, but I don't have a Windows available for streaming right now, so I can't show that, and it's like only like technical stuff, like boilerplate stuff, not really interesting. And although I'm really tired today, it's like 12:30 a.m. and yeah, it's getting really late. And yeah, so this is the end of this making a 4K intro season. Like, it was the first 4K intro that I made live on stream. The most of it, were quite a few parts that were done offline, and I don't think that I will stream the next one. The next one I will be doing mostly offline, but still I do have a schedule of streaming like Wednesday and Friday 9 p.m. Novosibirsk time, which is 4 hours ahead of Finland. and I think like 5 hours ahead of Central European time, and 13 hours ahead of like Pacific summertime or something. Yeah. So this is it for today. I will be still streaming some parts of development. I have plans for doing area light traders. I have plans for doing some sound DSP work if I'm able to. So yeah, if everything goes well, I see you on Wednesday. And yeah, thank you for watching. Thank you for participating in chat. And yeah, see ya. Bye.